Tangent. This is the third trigonometric function we're going to be working on in this little segment before we get into some inverse functions and whatnot. So tangent. So in the previous video, we determined that sine, let me do that a bit neater. We determined that sine is equal, sine of theta, I forgot about that part. We determined that sine of theta is equal to the opposite side over the hypotenuse. We determined that the cosine of an angle is equal to the adjacent side over the hypotenuse, but tangent is a bit special. So, as you can probably already tell, tangent also gets its own little prefix here. It's tan or tan, but tangent is a bit different. So, tangent of an angle, let me do that a bit neater. That's not even any better. Tangent of theta, so tangent of an angle, is equal to the opposite side over the adjacent side. And this is a bit interesting. So if you remember from last video, I did this little thing where I did S-O-H, C-A-H, and this would be T-O-H. So it goes the function name, the numerator, and the denominator, function name, numerator, denominator, function name, numerator, denominator. So it's actually a fun little saying or little string of characters you can come up, and it's called SOHCAHTOA. It's a bit interesting, but it goes a little something like this. And if you just say this out loud, it kind of sounds like SOHCAHTOA. So there's a neat little trick to remember all the trig functions and their ratios, all these trig ratios here. So sine is opposite over hypotenuse. Sine is the opposite over hypotenuse. Cosine is the adjacent over the that's not supposed to be an O. That is not supposed to be an O. I meant an H here. I did not mean an O. I got a bit caught up here in writing this. The adjacent over hypotenuse, and then tangent is equal to opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now let's visualize tangent here. So if we take a triangle, in fact, let me move that down here. Tangent is a bit different. So this hypotenuse side, this does not matter. This does not matter whether you're getting the tangent of that angle or you're getting the tangent of this angle, right? So that's angle A. Let's make that a bit bigger. So that's angle A. That's angle B. So the tangent of angle B would be the, alright, let's say that's X. Let's say it's Z, just like we've done in the past. The tangent of angle B here would be the opposite side, which in this case we can say is Z, because it does not make up this angle B here. So Z over the adjacent. We know that this is the adjacent because this is the hypotenuse. The hypotenuse and the adjacent side make up the angle that we're getting or we're working with. This is the hypotenuse, this must be the adjacent, so this right here is X. So the tangent of B, I'm just going to write it one last time. The tangent of angle B is equal to Z over X in this instance. Now what if we were to get the tangent of angle A? So tangent of A is equal to the opposite side. So the opposite side is X now, because that does not make up the angle A. And the adjacent side. Well, you could say H is the adjacent, but H is actually the hypotenuse, so Z must be the adjacent. So X over H here. So tangent of A is X over H. Tangent of B is Z over X. And that is a quick visualization. Now, let's work with some real numbers like we have previously. We always like to work with real numbers here. I'm going to use my favorite Pythagorean triplet, the 3, 4, and 5 triangles. And then we're going to say this is, let's think of a new angle here. Let's do 50, let's do 53. I think 53 is something fresh for us. 53, so this must be 37, and then we obviously know this is a 90-degree angle because it's a right triangle. So if we were to get the tangent of angle 53 here, so tangent of 53, this in this instance with these numbers, tangent of this angle 53 here would be equal to the opposite side, which the opposite is 3, the opposite side over the adjacent side, which the adjacent side is 4, because the angle here, the adjacent is the line segment that's not the hypotenuse that makes up the angle. So this is the hypotenuse, so it can't be that, it must be 4. So tangent of 53 is equal to 3 over 4. Now if we were to get the tangent of 37, that's just going to be a bit different. So tangent of 37, that would be the opposite, which is 4, and the adjacent, which is 3. So 4 over 3. So those are the tangents, and I hope that helps you guys understand the tangent function. So I guess let's go over everything one last time just to refresh our memories, and so we're aware of everything, and that this gets hopefully stuck in your head for at least a little bit so you can practice a bit more. So sine, like I mentioned, sine of an angle, sine of theta, is equal to the opposite side over the hypotenuse. Cosine of an angle, cosine of theta, is equal to the adjacent side over the hypotenuse. And tangent of theta, tangent of an angle, is equal to the opposite side over the adjacent side. The fun little acronym, or little saying that we have here is SOHCAHTOA. So SOH, CAH, we didn't use O again, and TOA. It's not really SAC, it's SOC, but still, it's a fun little term that we can use to help remember this. And if it helps, typically when you break it down, it's the trig function, the first letter of the trig function, the numerator, and then the denominator, and that applies for all three here. C is the first letter of cosine, A, adjacent, is the numerator, and H, the hypotenuse, is the denominator, and that applies to all of them. So hopefully this helps you guys understand all three trig functions, sine, cosine, and tangent. It's also important to know that these aren't the only trigonometric functions. There are a lot more trig functions, but we're really only going to be focusing on these three, and then we're going to get into inverse functions and arc functions, and we're only going to be touching upon inverse functions for about one video, and it's very brief. We're not probably going to do much work with it, but we are going to be working with arc functions soon. So I hope this helps you guys understand the three trigonometric functions. That's the introduction to tangent.